Welcome back, everyone, to the deep dive. Today, we are all about getting those quick wins with MySQL.
It's about the low-hanging fruit.
Exactly. No matter how much experience you have with MySQL, we're going to help you level up your game quickly. We're diving into a talk called The Low-Hanging Fruits of MySQL.
Catchy title.
It is by Kedar Vaijnapurkar. This guy's a MySQL DBA with 15 years of experience under his belt.
You've seen it all.
He's seen it all. So we're going to cover his tips, his tricks, his insights on those little things you can tweak to make a huge difference in performance.
Yeah, you'd be surprised how many people just skip over these basic optimizations.
Exactly. So we'll be talking about everything from how to squeeze more performance out of your server with just one configuration change to why using text to store text can be a terrible idea.
Let's jump in.
Yeah, let's jump in. Where do we start?
Well, let's start with a MySQL configuration file. You can think of it like the control panel for your database.
Okay. The control panel.
And there are some key settings that can really unlock hidden potential.
It's like a treasure chest of secret performance boosts. I like that.
So the first variable we'll talk about is init buffer pool size.
Okay.
Now, this is where MySQL keeps its most frequently used data in memory, ready for super fast access.
So this is like a special VIP area where we keep the most important data right up front.
Yeah, think of it like a VIP lounge for your most popular data, keeping it close at hand instead of making it go through the hassle of coming in from the disk.
I got it.
So the key takeaway here is make sure you are giving that init buffer pool size enough RAM.
Oh, okay.
This can be the single biggest performance booster for your database.
Wow. Just one setting.
Seriously, Kedar recommends dedicating up to 80% of your available RAM to this variable if your server is primarily a database server.
Wow, that's a lot. So that means this one variable could make a massive difference.
It can. And now, to make that VIP lounge even more efficient, especially when you have a lot of activity happening, there's another variable called init buffer pool instances.
Okay, more instances, more VIP lounges.
It's kind of like dividing that VIP lounge into smaller, more specialized sections, so things don't get too crowded.
Yeah, that makes sense.
This allows multiple queries to access data simultaneously without stepping on each other's toes.
So it's about efficiency.
But, and here's a little word of caution from Kedar, more isn't always better with this one.
Okay.
You need to find the right balance based on your setup and how many concurrent users you have hitting the database.
It's always about finding that sweet spot. Okay, let's move on. Another performance tweak. Autorect.
Yeah, this one sounds a bit technical.
It does, but I'm curious.
Yeah.
What is this autorect?
So autorect is basically a way to tell MySQL to bypass the operating system's cache when writing data to the disk.
Cutting out the middleman.
Exactly, like taking a direct flight instead of a layover. It can be faster, right?
Yeah.
Especially beneficial on those dedicated database servers where you have more control over the hardware and the operating system.
Oh, okay.
But, and I think this can be a recurring theme, Kedar emphasizes benchmarking.
Of course, benchmarking.
What works well in one environment might not in another.
Always got to test it out.
Exactly. So test and measure to see if autorect actually moves the needle for your particular setup.
Now let's talk about log files.
Okay.
Kedar has some interesting advice about log file size that goes against what you usually hear.
It does. So he actually recommends using larger log files.
Oh, really? I thought smaller was better.
You would think, but actually larger log files can improve performance by reducing the frequency of those checkpoints.
Okay, explain checkpoints.
So a checkpoint is when MySQL writes modified data from that buffer pool we talked about earlier to the disk.
Got it.
So with larger log files, you have more breathing room, right? You don't need to do those checkpoints as often. That means fewer interruptions to the database's flow.
So it's like having a larger notebook to write in. You don't have to stop and sharpen your pencil as often.
Exactly. And Kedar recommends sizing your log files based on your peak hourly traffic to ensure that smooth operation.
Okay. Peak hourly traffic. Got it. So we've got our init buffer pool size, we've got autorect, we've got our log files. What else is there?
One last thing in this section, let's touch on the query cache.
Oh, the query cache.
Kedar, he doesn't use it that much anymore, and he explains why in his talk.
I thought the query cache was supposed to speed things up by storing query results in memory.
Yeah, that's the idea.
Huh.
But in modern systems, well-optimized systems especially, the query cache can become more of a hindrance than a help.
Really?
It's true. It's kind of like, holding on to yesterday's newspaper. You're better off getting fresh information.
Got it.
So modern caching solutions at the application level or dedicated caching systems are usually the better bet these days.
So query cache is a little bit outdated.
A bit.
Okay, we've covered some key configuration tweaks. Now I'm interested to hear Kedar's thoughts on system-level optimizations. MySQL doesn't exist in a vacuum, right?
True, very true. MySQL performance is very tightly connected to the operating system that it runs on. So Kedar's got a few recommendations for some system-level tweaks that can really move the needle. For example, he suggests separate mount points for your data files and log files.
Separate mount points. I mean, isn't that more about organization than optimization?
It's both. Separate mount points give you the ability to fine-tune your disk I/O settings for each type of data,
Oh, okay.
leading to smoother operations and potentially better performance.
Mhm.
You could optimize the mount point for your log files for sequential write operations, which is how they're typically accessed.
So it's like having dedicated lanes on a highway for different types of vehicles.
Exactly, keeping everything flowing smoothly.
What about this swappiness beast that Kedar mentions?
The swappiness
What
beast.
is swappiness?
Swappiness is a setting in the Linux kernel that controls how often the system uses swap space,
And swap spaces.
basically using your hard drive as extra RAM.
Yeah.
Now, the problem is accessing data on your hard drive is way slower than accessing it in RAM,
So we want to avoid swapping at all costs.
as much as possible. So Kedar recommends minimizing swappiness,
Okay.
but not disabling it completely. You still want that safety net in case there's a sudden memory spike.
Okay, so don't completely get rid of it.
It's like having a spare tire, right?
Yeah.
You hope you never have to use it.
Yeah.
But it's good to have in case of emergency.
All right. Now, another little tweak he mentions is disabling those access time updates on your database files.
Ah, yes.
What are access time updates and why disable them?
So every time a file is accessed, Linux updates its timestamp,
Okay.
and that involves writing to the disk. For database files, which are constantly being accessed, these updates create unnecessary overhead.
Okay.
So by disabling them, you're eliminating those pointless trips to the disk,
Makes sense.
which can slightly improve performance. It's like turning off those annoying notifications that you don't really need.
Got it. And finally, the I/O scheduler.
Ah, the I/O scheduler.
What is this?
So the I/O scheduler determines the order in which disk read and write requests are handled. There are a bunch of different I/O schedulers available.
Mhm.
And Kedar generally recommends using the Noop scheduler for database workloads.
Nope. So it does nothing.
It's more like it takes a hands-off approach.
Okay.
Basically passes those requests through in the order they were received without trying to be fancy.
Got it.
And this is often the best approach for databases because they usually have their own internal mechanisms for optimizing I/O.
So let MySQL handle it.
Exactly.
Okay. Configuration file, check. System level optimizations, check. What's next?
Well, now we have to get to the foundation of it all, database design.
Okay.
Kedar stresses the importance of solid database design principles, and his insights here are really valuable for ensuring long-term performance and efficiency.
Okay. So let's dive into that next time.
Sounds good.
We'll be right back.
All right, so picking up where we left off, database design, it's like building a house, right?
Okay, building a house.
If you get the foundation right, everything else becomes so much easier and more efficient.
Yeah, that makes sense. So where do we start with this foundation?
Well, Kedar, he's a big proponent of using InnoDB as your default storage engine.
In a DB, yeah, that seems to be the go-to these days for most people.
It's the gold standard.
It is. Why is Kedar such a big fan?
Well, InnoDB offers a lot of advantages, especially when it comes to performance and reliability.
Okay.
It's got that great transaction support, crash recovery capabilities, and support for foreign key constraints, which are really essential for data integrity.
You don't think about data integrity until it's gone.
Exactly. And plus, InnoDB is designed for high concurrency,
Okay. High concurrency meaning.
meaning it can handle lots of users accessing data at the same time without, breaking a sweat.
So it can handle the heat.
It can handle the heat.
Okay. So InnoDB is the workhorse, keeping things running smoothly behind the scenes.
I like that. And speaking of keeping things running smoothly, one of Kedar's biggest pieces of advice is to make sure every single InnoDB table has a primary key.
Oh, a primary key. I thought those were optional.
Not with InnoDB.
Yeah.
They are essential. And it's not just about uniquely identifying rows. They actually play a key role in how the data is organized and accessed within the table.
Okay.
Without a primary key, InnoDB has to create its own internal, like a hidden row ID, and that can add overhead.
So it's better to be organized from the start.
Think of it like having a well-organized filing system, versus just throwing all your papers into a random drawer.
That's me.
So, and when it comes to choosing your primary key, Kedar really recommends sticking with simple auto-incrementing integers,
Sticking with the basics.
sticking with the basics.
Why auto-incrementing integers? What's wrong with using other data types like strings or those UUIDs that everybody's talking about these days?
So remember, InnoDB uses what's called a clustered index,
Right.
meaning the entire table is organized based on that primary key.
Okay.
So when you use something like a string or a UUID as the primary key, you're basically making MySQL do a lot of extra work.
Okay.
Reorganizing the table as new rows come in with different length keys
Right.
can lead to fragmentation, performance hits.
So it's like, I'm trying to think of an analogy here. It's like trying to organize a bookshelf alphabetically, but all the books keep changing sizes.
That's a good one. And, auto-incrementing integers, they provide that nice sequential order,
Keeping things nice and tidy.
keeping everything neat and tidy. And actually, while we're talking about integers, Kedar brings up a small but potentially impactful optimization
Okay, I'm listening.
using unsigned integers when it's appropriate.
Unsigned integers, what's the difference there?
So an unsigned integer, it can only store positive values,
Okay.
while a signed integer can store both positive and negative. So if you know for certain that a column will only ever hold positive values, like a quantity or a count, using an unsigned integer can save you a little bit of storage space.
So it's like getting a slightly smaller box to store something that doesn't need a lot of room.
Every little bit helps. Now, switching gears a bit, Kedar has a word of caution about the text-t data type. It seems counterintuitive, but he recommends avoiding it whenever possible.
Avoiding text T, but isn't that the data type for storing like big blocks of text?
It is. But there's some consequences.
Yeah.
Large text-t fields, they can cause data pages to get fragmented, which means more disk I/O, which means things slow down.
Okay.
So he suggests using varchar instead,
Oh, really? Even for long pieces of text?
as long as you can define a reasonable maximum length.
So again, choosing the right tool for the job.
Exactly.
Oh.
All right, now let's move on to the art of speaking MySQL's language. We're talking query optimization. This is where we can make a huge difference in performance
Okay. Query optimization.
by crafting efficient queries. It's like learning the secret handshake to get things done faster in the MySQL world.
I like that, the secret handshake.
Yeah.
All right, what's the first rule of the secret handshake?
So first things first, Kedar points out the importance of being selective about the data you retrieve. He strongly discourages the use of selecto.
Selector, but that's just a shortcut, right? To select all the columns. What's wrong with that?
Seems convenient.
Deserves.
But selecting all the columns when you only need a few can be a real performance drain.
Really?
Increases the amount of data that needs to be transferred, from disk to memory over the network.
Okay.
It's like going to a buffet and piling your plate with everything, even though you'll only eat half of it.
Been there, done that.
So always be mindful of what you need and select only those specific columns.
Be picky.
Be picky. Another pitfall Kedar points out, putting too much logic into your SQL queries.
Oh, so no more writing novels in the where clause.
Exactly. Keep it simple, complex business logic. That's better handled in your application layer, where you have more flexibility.
Okay, yeah, that makes sense.
So keep those SQL queries lean focused. It's like trying to bake a cake using only a microwave. It's possible, but it's not going to be pretty
Or efficient.
or efficient. Now, for those times when you really need to understand how MySQL's running your queries, Kedar recommends using the explain command.
Explain.
It's like therapy for your queries.
Okay. Therapy for your queries.
It shows you the execution plan, revealing which indexes are being used, how many rows are being scanned, all that good stuff. It's an invaluable tool for finding those bottlenecks. And, if you need to give MySQL a little nudge in the right direction, you can use what's called optimizer hints.
Optimizer hints. Are those like, I don't know, slipping the matrix to 20 to get a better table at a restaurant?
Not quite.
Mm-hmm.
They're more like directives that you can add to your queries to influence how they're executed.
Okay.
Particularly useful for, long-running analytical queries. You might have a better understanding of the data distribution. But use them sparingly. Sometimes they can have unintended consequences. It's like giving MySQL some friendly advice, but trusting its expertise to make the final decision.
Makes sense.
Now, 2 more quick pitfalls to avoid. Kedar warns against these: leading wildcards and wrapping your indexed columns and functions.
Leading wildcards, you mean like searching for percent something instead of something percent?
Exactly. When you do that, MySQL can't use the index effectively.
Right.
Has to scan the entire column,
Right.
which can be really slow.
Mm.
And similarly, if you wrap an index column in a function, you're basically putting a disguise on your data. MySQL can't recognize it with the index anymore.
Ah, okay.
So by avoiding these pitfalls, you're really helping MySQL leverage those indexes, keeping those queries running smoothly. Now, let's move beyond single server optimization and dive into the world of replication.
Replication. Okay, so now we're talking high availability, disaster recovery, all the mission critical stuff.
Exactly. And one of the first things Kedar emphasizes is that replication is not a backup.
Wait, what? I thought replication was all about having a copy of my data somewhere else, just in case.
It is. But it's not a replacement for a solid backup strategy.
Okay, I'm listening.
If you accidentally delete data on your primary server, guess what?
Uh-oh.
That deletion gets replicated to your replicas. So it's like having a mirror. It reflects your mistakes as well as your successes.
Got it. Replication is not a backup.
You still need a dedicated backup strategy, whether it's accidental deletion, hardware failure, whatever. Something to protect you from that data loss.
Okay. Replication for high availability and redundancy, backups for true disaster recovery.
That's a good way to put it. Now, when it comes to replication, Kedar does have some cautionary advice about those multi-master setups.
Multi-master. Isn't that where you can write to multiple nodes at the same time?
It is.
Doesn't that seem like a recipe for disaster? Like conflicting data and all sorts of problems?
It can be if you're not really, really careful.
Okay.
So multi-master, it introduces the risk of data conflicts.
Oh.
If those rights aren't carefully managed.
Yeah. Seems risky.
It is. It's like having two chefs trying to cook the same dish at the same time, but with different ingredients and different instructions.
Yeah, that's not going to turn out well.
No. So Kedar, he actually advises against writing to both nodes in a multi-master setup unless it's absolutely necessary.
Okay.
And you have really robust mechanisms in place to handle those conflicts.
Got it. So probably better to just stick with one master, right? And have the other nodes be read replicas.
It's like having one head chef ultimately in charge.
Makes sense. What about those times when a replica starts lagging behind? I've heard horror stories about replication lag bringing down entire systems.
Replication lag can be a real headache.
It can.
But Kedar has some good advice on how to minimize it. First, he says that your replicas should be provisioned similarly to your master server. They need to be able to keep up.
So don't skimp on the hardware for those backup singers.
Exactly. And to help those backup singers keep up, Kedar brings up the concept of parallel replication.
Parallel replication.
So traditional replication, it's single-threaded,
Okay.
which can be a bottleneck, especially when you're applying those large transactions or have tons of updates happening.
Right.
Parallel replication, it lets MySQL use multiple threads to apply the changes. So it really speeds things up. It's like having a whole team of stagehands working behind the scenes.
To keep the show running smoothly.
Precisely. And one more technique for dealing with those potential hiccups with replication is using delayed replicas.
Delayed replicas. Why would you intentionally slow down replication? Doesn't that defeat the purpose?
Well, think of delayed replicas as kind of like a safety net. They're configured to lag behind the primary server by a specific amount of time.
Okay.
Now, this can be really helpful if you accidentally make a change on your primary server that you need to undo.
Oh, so it's like having a rewind button for your database?
Exactly. If you delete data on your primary server, you can switch to the delayed replica, which will still have that data.
That's a clever trick.
It is. And just one more crucial configuration setting when it comes to replication.
Okay, hit me with it.
Log slave updates.
Okay, log slave updates.
This setting determines whether a replica writes its own binary logs, which is essential if you want to chain replicas or potentially promote a replica to become the new master in the future.
So it's like making sure your understudy is ready to take the lead role.
Exactly.
Okay, so we've covered a lot with replication.
We have.
Now let's talk about the most important thing. Backups. Backups, the most important topic when it comes to MySQL or really any database.
It's true. It's your insurance policy, right? No matter how much you optimize, you got to have good backups.
Exactly. So let's get into those backups and see what Kedar's got to say.
All right, so first tip, a bit of a surprising one.
Oh, I'm intrigued.
Don't run backups on your primary server.
Wait, what? I thought that was the most important data source. Why wouldn't we back that up?
It's all about minimizing performance impact on that primary server. Remember, backups, they're resource intensive.
Okay, yeah, I guess they are.
Putting a strain on your server if it's trying to handle live traffic at the same time.
It's like trying to pack for a trip while hosting a dinner party.
I like that analogy.
It's not going to go well.
So Kedar, he recommends offloading those backups to a replica server or even a dedicated backup server if you have one.
Okay.
Keeps your primary server focused on what it does best, serving your application.
Makes sense. Okay, so offload those backups. What else have we got?
All right. So Kedar also has a story about why just having a backup isn't enough. You need to actually test them.
Test backups. How do you test a backup?
So he actually had this situation where a backup, seemed to complete successfully, right? But when he actually tried to restore it, the data was corrupted. Turned out there was a problem with the storage system that didn't get flagged during the backup process.
So you just assume everything is fine, but then when you need it, it's not there.
It's like having a fire extinguisher, but you never checked if it was charged. Not very helpful when you need it.
and not helpful at all. So we need to test those backups.
Regularly. Restore them to a test environment just to make sure that they are truly usable when you need them.
Backup validation. Okay, got it. Where do we store those backups?
Ah, yes. Storage. Imagine this, the worst case scenario. Fire, flood, something happens that takes out your primary data center. Now, if your backups are stored in that same location, poof, they're gone.
Don't put all your eggs in one basket.
Exactly. So Kedar recommends storing backups in a separate geographical location. Could be a remote data center, cloud storage like S3 or Google Cloud Storage, even just a simple offsite tape backup if that's what you're using. The key is to have a copy of your data that's safe from that localized disaster.
Makes sense. Offsite backups for the win.
Absolutely. Now, Kedar also talks about these concepts, RTO and RPO.
Okay, RTO, RPO, I've heard of those.
So RTO is your recovery time objective.
Mm-hmm.
Basically, the maximum acceptable downtime that you can handle.
Okay, downtime.
RPO is your recovery point objective. So that's the max data loss that is acceptable.
Okay, so it's really figuring out how much downtime and data loss can your business handle.
Exactly. So if your business requires a really short RTO, you're going to need a solution that allows for that near instant recovery, like maybe point-in-time recovery or log shipping.
Right.
If data loss is a big concern, then you need those frequent backups and a low RPO.
So customize it to your needs. All right, we've covered configuration, we've covered queries, we've covered replication, we've covered backups. What else is there?
We got to talk about Kedar's secret weapon, the Percona Toolkit.
The Percona Toolkit.
Yeah, it's this collection of open source command line tools that are just super helpful for any MySQL DBA.
Like a Swiss Army knife for my school.
It is. It is.
Yeah.
And, it simplifies all sorts of tasks. We're talking schema changes to performance analysis to replication management. You name it. The Percona Toolkit can help.
Okay, what are some of his favorite tools?
Well, one of the top picks is Keat Online Schema Change. This tool lets you make those schema changes, adding columns, adding indexes, without taking your system offline.
So it's like doing open heart surgery on the database while it's still running?
That's a good one.
What else have we got?
Another handy tool, PT-Kill. Now, this one helps you regain control if you have a database that's just gone haywire.
Oh,
It lets you terminate those queries, the ones that are causing trouble.
it's like a bouncer for your database.
I like it. And if you ever need to fix those data inconsistencies between your master and those replicas we talked about, Kedar recommends this powerful combo. Pete Cable Checksum and ptable sync.
Two tools.
Two tools. The first one helps you find the discrepancies,
Okay.
and then the second one helps you sync the data to make sure everything's consistent. And then to help you find those slow queries, the ones that are dragging down your performance, there's Pete Query Digest.
Okay.
This tool analyzes those slow query logs and helps you pinpoint the queries that need some love.
Like a detective for your database.
It is. And one more that he recommends is P-Duplicate Key Checker. This one helps you find and get rid of duplicate indexes, which can actually hurt performance.
Spring cleaning for your database.
Exactly.
Wow, I think we've covered it all.
We have covered a lot.
Configuration, queries, replication, backups, and even the Percona Toolkit.
It's been a great journey.
It has. And, it's a good reminder that sometimes we don't need those really complex solutions to solve these common problems. It's those simple, practical tweaks that often have the biggest impact. So try out some of Kedar's advice. Experiment a little, see the difference it can make. Until next time.